We're going to sketch another cubic equation here, and this time we're going to use something called the factor theorem to figure out how to figure out the x-intercepts. And well, let's just get started. So we've got 5 steps that we've done. Now this is the final graph we're going to have. And how the heck did we know that this graph was going to be this shape? Well, we look at the number in front, and if that's a positive number, which is a 1, that means we've got the shape of this thing. So there's that right. The next easiest thing is to let x equal 0. That's all be nothing, and y would equal minus 36. Now here's the part that's a little bit harder. We're going to find the x-intercepts by letting y equal 0, like we would with any function. But how are we going to factor this whole long thing here? Well, there's something called the factor theorem, and all we have to do is first look at this number 36. What are all the things that go into 36? Now it turns out 1, 2, 3, 4, 6, there's a whole bunch. But if we start with these smaller numbers that go into 36, we got a pretty great chance of figuring out what the zeros are, the things that would make y equal 0. So all we do, we start off first with 1. We put 1 in here, we put it into our calculator or maybe our heads, and wow, f of 1 equals 0. But what's the deal with that? Well, if f of 1 equals 0, then x minus 1 is a factor, and that's the factor theorem, and that's really all it's about. Now we might try minus 1, we 2, minus 2, 3, minus 3 wouldn't work. But if we try 4, whatever makes it 0, that's an x-intercept. It makes y 0. So that means x minus 4 is a factor. Well, we're kind of now looking at our answer. All we do is write x minus 1, x minus 4, and then x with something here. Well, we look back up. It's got to equal minus 36. Well, minus 1 times minus 4 is positive 4. That means this must be minus 9. And there it is, all factored. B must be minus 9, so that means x is 9. 9 minus 9 makes it 0. There's our zeros. And that's how Mr. Autry did it slightly different. Maybe he got x minus 1, and then he put x squared and 36 and did this thing called inspection. But we didn't do it here. We just kept trying factors until we got them, and we barely had to do anything. The only inspection we had to do is minus 1 times minus 4. What would I multiply it by to get minus 36? Must be minus 9. There's the whole thing done. 1, 4, and 9. Okay, there's your x-intercepts. We got the y-intercept, we've got the x-intercepts. What about the turning points? Before we graph, we would try and get the turning points. What do? We take the derivative of this x cubed minus 4x squared, and we get 3x squared minus 28x plus 49. Now you factor this or use a quadratic formula, you get 2 x values. You take the x values, you put it back into the original equation, and you get 2 scary numbers. You get 400 over 27. You could write it as, if it's 18 point, I don't know what it is, but it's 7 over 3 and 400 over 27. That's the turning point right over here. And 7 is the other one. And if you put 7 in here, into the original equation, you get minus 36 out. There's your turning points. Last thing is the point of inflection. We just take the derivative of this, 3x squared minus 20, it gets 6x minus 28, add 28, divided by 6. There's the x value of the inflection point. Sometimes they just ask for that. But if they want the y value, just take 14 over 3, put it into your little powerful calculator, and it'll tell you it's minus 126 over 27. So it's negative something there, negative 3, but negative whatever it is. Yeah. And there you go. Actually, that moment must be something like I don't know if it's 27. Maybe it's a little bit bigger than that. But anyways, that's what you do. You take that number, and you put it in your calculator into the original equation. That's how you get the point of inflection. And there you go.